Hello everyone, and thank you for joining me in Tracerco's online presentation on gamma scanning trade and packed columns. My name is Thomas Rhoda, your technical advisor for Tracerco's Process Diagnostics division. In today's presentation, you will learn how Tracerco's tower scanning technology can help with reduced downtime, plan and save money for upcoming outages, optimize your process performance, and help with troubleshooting. Before we start, I want to remind everyone that the health, safety, and well-being of our employees and customers is our #1 priority. And since we will be talking about tower scanning today, I thought it would be a good reminder to state the importance of routine inspections on fall arrest equipment before and after each use. Remember, our personal protective equipment is designed to reduce injuries, so we must make sure that they are always in good working condition. If you're not familiar with Tracerco, we take pride in measuring the unmeasurable, accessing the inaccessible, and help solving the impossible. We are the originators of gamma scanning and tracer technology, with over 60 years of experience delivering innovation to the upstream and downstream energy industry. We have offices strategically located across 5 continents, where we are able to collaborate with industry professionals throughout the world and respond to customer needs rapidly. Today's presentation will focus on the value of gamma scanning trade and packed columns using Tracerco's trademarked TrueScan, FrothView, PackView, and ThruVision technologies. We will cover topics such as identifying tray damage, flooding, foaming, tray capacity, and distribution. At the end of the presentation, there will be a time for a questions and answer period, so please save your questions until the end. Let's start with trade columns. This can include distillation or contactor columns with a variety of tray designs. So just because you might see an example with a single pass tray design, that doesn't mean it doesn't apply to 2, 3, or 4 pass tray designs. And the same goes with the design of the tray itself, whether it be a bubble cap tray, or a valve tray, or any other type of tray. But first, what is gamma scanning? Well, gamma scanning has been around for over 50 years and uses a small radioactive source and a sensitive detector to directly measure process conditions and mechanical integrity. Everything is done external of the column with no interaction or interference to the process. The response seen at the detector is directly related to the density the gamma wave sees as it passes through the column. So the higher the response measured at the detector, the lower the density of the material in the column. And vice versa, the lower the response, the higher the density. The results are not theoretical nor calculated, but actual, real-time measurements while the process equipment is operating. Using the data from the detector and our industry-leading software, a TrueScan is able to plot the data on a chart that provides the valuable information such as tray damage, froth height, foaming, weeping, and tray capacity. Here is an example of such a chart of a single pass trade column. The horizontal axis shows the radiation intensity on a logarithmic scale. The vertical axis depicts the height of the column and where the trays are situated. The data is collected and plotted as the column is scanned from top to bottom, with a clear vapor bar placed beside the chart, which indicates the highest amount of radiation the detector would see if a gamma source was passing through vapor. The froth height is determined by measuring from the tray line to the intersection of the scan line on the clear vapor bar. The distance is then divided by the tray space. And that froth height is represented as a percent tray space, which is also a measure of percent flooding. Being able to look into the tower provides valuable insight. One of those many values is its ability to find damaged trays. A tray damage is any condition such as corrosion, down manways, or displaced panels that prevents the tray from supporting a liquid level. In this example, scan results show the density of the trays in the bottom 12 are much lower than observed in the top 8. Therefore, severe corrosion or tray damage is suspected. Now, knowing tray damage without having to shut down allows clients to know how many replacement trays to order beforehand and plan for a faster shutdown, saving plants money. This can also confirm or deny any other issues they might be suspecting, saving more time and money on other planned tests. Another value that a TrueScan provides is showing flooding inside the column. In a column operating under normal conditions, a gamma scan would show absorptions on top of each tray, followed by a return to the clear vapor bar, which depicts the vapor space above that froth or liquid. In this example, a column was experiencing a cyclical rise and sharp fall in differential pressure, with an inverse effect on the temperature indicators. The top section shows the decent vapor space above each tray, but when you get below tray 7, you can clearly see where the flooding is starting to occur, as there is no return to the clear vapor bar. Instances of severe fouling on trays may lead to flooding, and a TrueScan has proven to be a reliable tool for determining the exact location and extent of flooding, because scans measure the liquid holdup in a column directly. In addition to solving flooding problems, TrueScan analysis can assist in improving operating procedures for pushing a column to its maximum capacity. This is accomplished by our state-of-the-art froth view technology. Developed to determine the amount of percent tray space being utilized, this method was proven by real research and testing and found to be the most effective method for measuring true froth levels on trayed columns. Results are closely in line with theoretical percent flooding and very relatable to process engineers. Now, the development of the technique and data interpretation was customer-driven. Clients asked us to provide a more useful and accurate froth height measurement, and we delivered with the industry-leading froth view. You can see from this picture how froth view gives a much more accurate representation of the froth level compared to the old industry standard method. On the scan plot, it shows the total froth heights labeled for each tray. Percent tray spacing is Tracerco's term to show the amount or percentage of available tray spacing that is occupied by froth or aerated liquid. Again, our goal with the froth view method is to measure the very top of the froth layer. With this patented technology, customers can maximize production or determine bottlenecks in their operations. In this study, an engineer was wanting to increase production, but their tower seemed to be the bottleneck for the rest of the unit. The client elected to perform 3 true scans at low, mid, and high rates on their tower. The first scan, performed at lower rates, and shown here, showed the trays to be holding between 50 and 70% of tray spacing. compared to in-house simulations that indicated at these conditions the tray should be around 50 to 60% of tray spacing. The second scan at mid-rates, and illustrated here by the red scan line, showed that most of the trays were operating between 70 and 95% of tray spacing. In-house simulations in these conditions indicated they should have been around 70 to 80% tray space. The third scan, at high rates and illustrated by the black scan line, showed the trays operating at 100% tray spacing, indicating flooding. There was also a froth height measured of 22 to 24 inches above the top tray, which was encroaching on the top tangent line and into the overhead. Now, modeling showed that the trays should have only been at around 80 to 90% flooding, which was obviously not the case. Now, knowing this, the client was able to redesign the trays by increasing the whole area on the active panels to reduce pressure drop. They could now reach their new product rates without adversely affecting overhead material purities. Being able to remove the bottleneck to the rest of the unit, the customer was able to increase its throughput with the help of utilizing Tracerco's froth view technology. Another value in Tracerco's TrueScan is its ability to detect foaming and be able to maximize production without causing more foaming. Now, foaming is apparent in a gamma scan plot because of the change in slope on the plot line. This is due to the change in density of the foaming. In this example, a column was scanned at low rates and found the top section of the tower behaving relatively normal, with some foaming happening at the bottom. They changed to high rates and scanned the column again, seen in red, and found the foaming and flooding only worsened. On the third scan, represented in green, they kept the rates the same but added an anti-foaming agent to the process. When rescanned, it was clear the anti-foaming agent was doing its job in removing the foam. Tracerco's TrueScan was able to help the customer identify the extent of the foaming issues and help maximize its production while proving foaming was no longer an issue. Okay, in wrapping up trade columns, a TrueScan has proven to be a valuable tool to inspect a column while it is online. It provides insight into troubleshooting and determining mechanical issues of the tower. Now, traditionally, these problems might only be identified while the column is down for an offline inspection. Not to mention, this allows for the inspection to be completed without lost production time, which could be the biggest cost savings of them all. A TrueScan has also proven its value in pre-turnaround and baseline scans, where here understanding any potential mechanical issues beforehand allows for decreased downtime for the repair, as you are now able to properly plan for any upcoming turnarounds. And then in fouling services, a baseline scan provides a profile of the column internals when they're at their cleanest, which is why it's called a baseline. Then the column can be scanned over time to monitor that buildup, which can help establish operating parameters that may slow the fouling process down and prolong running times. This will give you a better idea of when the fouling is nearing critical levels and then allows you to plan for an outage instead of having to shut down on an emergency basis. And this in turn, again, reduces downtime. Finally, a TrueScan allows for optimization studies to be performed, allowing you to determine bottlenecks and increase throughputs. Remember, results are reported the same day as service, allowing for decisions to be made more quickly. Alright, we will now move on to scans of packed columns. The same concept as scanning a trade column with a radioactive source and a sensitive detector, but approached slightly differently to get the data you need to make better decisions. Now, what kind of data can a gamma scan with Tracerco's unique PackView technology provide? Let's dive in. So, a true grid scan can verify the placement of packing, distributors, and collectors, while also providing data on the quality of the liquid phase distribution through the packed bed. This is accomplished by completing 4 scans through the bed, as a grid pattern shown here in the image. This effectively can detect problems such as fouled or crushed packing, overflowing distributors and collector trays, and flooding or foaming. Again, just like a true scan, everything is done external of the column with no interaction or interference to the process. The response seen at the detector is directly related to the density the gamma wave sees as it passes through the column. Here is an example of a true grid scan performed on a packed column. The scan plot on the left is a baseline scan performed after a shutdown and is showing excellent liquid distribution through the packed bed. But the scan plot on the right is the true grid scan results over time that shows the progression of fouling buildup. You'll also notice on these grid scans that there is a separate scale at the packed bed location. Here, Tracerco has developed this new packed column technology called PackView. And PackView is an enhancement in our true grid scan detection capabilities and our data presentation. One of the in-depth features of PackView is the addition of this liquid retention scale on the true grid scan analysis. The density scale, as seen here, begins at the density of the dry or non-operating packing. The density scale to the left of the dry packing is the calculated density of the liquid retained in the bed of the packing. Now, as with a normal gamma scan analysis, if the 4 scan lines have matching liquid retention densities, the implication is that the liquid distribution is good. However, if there is a difference between the scan lines, the retention density gives us a numerical comparison from which to gauge the extent or the severity of any liquid maldistribution, which is obviously showing in this example here on the right. PackView allows the customer to determine the actual density differences as it is related to only the process material and any contaminants or fouling. This gives them the ability to better determine the severity of maldistribution. This secondary scale is easy to read, and also old historical scan data can easily be converted to PackView, as long as the packing bulk density is known. Now, PackView was another technique and data interpretation whose development was customer-driven. Tracerco continually strives for constant improvement of our techniques and our willingness to provide what exactly our customers are wanting. In this example, Tracerco was asked to scan a customer's mist eliminator in the upper portion of an operating vessel. The tower had been in operation for over 20 years, but had never been opened to inspect the mist eliminator. There was also an identical vessel with the exact same mist eliminator in it, which was also scanned during the same project. So Tracerco performed a true scan to identify the placement of the mist eliminator, along with the density responses in each of the quadrants. Here is a scan on the first tower. This showed no indication of any solid accumulations within the mist eliminator, as it was operating between 1 and 2 pounds per cubic feet above its 15 pounds per cubic feet dry density. Here is the second column, which again was the same design as the previous. Only when a true grid scan was performed here, the packed view liquid retention scale showed the mist eliminator to be holding between 60 and 75 pounds per cubic feet of solids. Now there also appeared to be about 2 inches of additional solids which had accumulated on top of the mist eliminator in the southeast quadrant. This is indicated by the red and green scan lines. The unit was shut down a few months later, and the client confirmed the true grid scan findings of the solids built up in the mist eliminator. They also elected not to open up the other vessel which had no signs of buildup, which saved them an additional 2 days off their shutdown, and in return saving them money and downtime costs. So using PackView to understand the extent of solid buildup proved to be an effective method in determining the appropriate maintenance path of these vessels. This now leads us to our final subject, which is profile mapping maldistribution using our industry-leading through vision technology. Tracerco's through vision scan procedure provides data that is very similar to a medical CT scan at a set elevation on a column. Now, this is completed by overlapping many different scan lines at several different angles until enough data is collected to provide an image seen here, a density profile map. Through vision then covers a much larger percentage of the cross-sectional area than a true grid scan does, and can identify equally maldistributed liquid, where the true grid scan will likely not identify those patterns. It can also be performed on other equipment, not just packed beds. Now, colors on through vision plots can be deceiving, so Tracerco also provides a table of the density distribution. And data from this density distribution table can be plotted to better understand the liquid distribution than trying to decipher several color circles. In this example, a high density area can be seen in the southeast corner. This is just another one of the many ways on how Tracerco provides insight into its customers' operations without having to go offline or interfere with the process. In this next example, a customer was experiencing off-spec product and called Tracerco to perform a true grid scan on the packed column. The scan, however, showed pretty decent liquid distribution, as seen by these scan lines overlapping pretty nicely. This was unexpected, so a through vision scan was performed to investigate further. As mentioned prior, through vision scans are performed at a single elevation, as indicated here on this scan plot. Here are the results of that through vision scan. Now, for this example, we overlap the orientation of the distributor in the column, as well as the scan lines of the true grid scan that was performed earlier. The blue spots showed a light liquid density, which was actually very near the density of the dry packing. The green areas showed a higher liquid density. Therefore, the through vision scan showed that most of the liquid was in the center of the column, with very little getting out to the ends of the laterals. The reason the true grid scan appeared to show good liquid distribution was because each of the 4 scan lines intersected the same amount of area in the dark blue. Therefore, when overlaid on the plot, they all appeared similar. In closing, through vision scans have helped customers throughout the world understand the extent of maldistribution and fouling by providing a real-time density profile map of the process. Again, everything is done external of the column with no interaction or interference to the process. The response seen at the detector is directly related to the density the gamma wave sees as it passes through the column. Results are reported the same day as service, allowing for decisions to be made more quickly. This brings us to the end of the presentation, and I would like to thank everyone for joining me here today on learning how Tracerco's tower scanning technology can help with reduced downtime, plan and save money for upcoming outages, optimize your process performance, and help with troubleshooting. We will now take any questions you may have.